welcome back to our last lesson for this particular unit. So this one is going to be on polyprotic substances. So just remember when you see that prefix poly means many, and of course if you see the word mono always means one. Now where this comes from, we can break it up at polyprotic, so this protic kind of means proton. And this is, we have a little explanation here on why we use that word proton. So normally the hydrogen ion is commonly referred to as a proton, mostly because when it loses its one electron to become the ion, only a proton remains. Now just a visualization of this, like if we did go back to our Bohr models and we know our hydrogen atom, it only has one proton in there and it doesn't have any neutrons, because if we do look at the periodic table, you can see hydrogen's right here, so it has an atomic weight of 1.01, so we can round that to 1, which means that it only has one proton because that's the only weight it has. If it had a neutron, then it would be 2 point something. So that's why we can just say that it has no neutrons whatsoever. Just let me find the notebook again. Here we go. And of course, where it's in position 1, it only has one electron. So we're going to add the electron here. So we have P positive is equal to 1, we have neutrons equal to 0, and we have electron is equal to 1. Now, as this forms the ion, we know hydrogen, to form the H+, it has to lose the electron. So now we have a nucleus, and our first energy level is empty. So when we count everything, we have one proton, no neutron, and no electron. So that is why the hydrogen ion, I forgot to put in the charge here, square bracket, positive 1. So that is why the hydrogen ion is normally considered a proton, even though it's technically not just a proton, but that's why for acids and bases we normally refer to the hydrogen ion as a proton based on this. So when it loses that electron, only a proton remains. No neutrons, no electrons. So what that means is that something like a monoprotic acid, mono meaning one, protic meaning proton, is acids that only have one acidic hydrogen in their compound formula, and only react once with water to produce the hydronium ion. Whereas polyprotic acids, these are acids that have more than one acidic hydrogen in their compound formula. So it's going to look something like this and can react multiple times with water. So for example, we have our H3PO4, so hydrogen phosphate. So 3 hydrogens means that it can react 3 times. Right? So that's what it means by having that multiple protons. So for example, reaction 1, we can get H3PO4 can react with water to produce HPO4 minus plus H3O plus. So just using the modified Arrhenius theory. Now, it should be H2. Now, I have a single arrow here showing that this reaction goes to completion. So if this reaction goes to completion, that means all of the H3PO4 is used up, and we're left with just H2PO4 minus H3O plus. So we can get our second reaction of H2PO4 minus reacting with water to leave HPO4 2 minus and then H3O plus, and of course it can react one more time where we get our HPO4 2 minus reacting with water, producing PO4 3 minus plus H3O plus. So that is how we can tell how many times something is going to react with water or anything like that, is we just need to see how many acidic hydrogens are there. Now, in general, polyprotic acids are weak acids whose reactions with water decrease each successive step. So that means that reaction 1 here is the strongest, reaction 3 is the weakest. So as we go down, reactivity decreases. So the only exception that we're going to see is H2SO4, so sulfuric acid. The first reaction is complete and the second one is less than 50%. But if you notice, we don't really deal with a lot of sulfuric acid because solving for concentration and stuff like that with it is a little more challenging. So we try not to do that one specifically in Chem 20. You deal with it a little bit in Chem 30. Now, for a monoprotic base, these are bases that can react with water, monoprotic. Remember, mono, one, protic, base, or protic meaning proton. So these are bases that can react with water once to produce hydroxide ion. And all ionic hydroxides are considered monoprotic, even if there are more than one, mostly because it doesn't really matter if you have CaOH2, it's because its dissociation happens in one step. It's not a two-step process, it's just a single step. So that's why even something like calcium hydroxide is considered monoprotic, because it's one step. Now all the other ones are considered, if it has to react more than once with water, it is going to be multiple or polyprotic because it can react many times. Now how we can tell what something's going to be polyprotic, we look at the charge. -2 means so that -2 meaning that, as we know, the hydrogen ion is positively charged. So that -2 means that it can pick up 2 positive hydrogens or react twice. So same thing as the other one. If we start with our polyprotic base, it can react with water. And remember, we're dealing with a base, so we need to form hydroxide. And of course, we can get another reaction where we finally get our final product like that. So you notice that every single time when I go to that successive reaction, I'm taking the product or the major product from the previous one, right, HCO3 minus, and now that is my reactant in the second equation, because if I'm drawing this arrow, I'm assuming that it's going to completion. So now it's the next one of the products is then going to react. So same thing with our acids, is that reactivity decreases as we go down each step. So CO3 2 minus is going to be the stronger base compared to the HCO3 minus, where this first reaction will react more vigorously, or it will react more than the second one. And that is how we can tell, basically for our polyprotic acids, we look at how many hydrogens there are, how many acidic hydrogens. For our bases, we look at the charge. And then as soon as you know how many times it can react, and these are the steps how we do our successive reactions going down through. So we write the first reaction only transferring 1 proton at a time, because that's how these reactions kind of go through. It's just a transfer of 1 proton, and that is it. So that is the last lesson we have. So just make sure to work on your workbooks, and of course this unit's over now, and our next unit will be stoichiometry. So we're going to be dealing with lots of calculations and stuff like this. So make sure to please work on your workbooks, review the stuff, and of course if you have any questions, make sure to email or attend our Google Meet on Thursday. So anyway, I'll see you guys later, and get ready for your last unit for Chem 20.